Hello everyone. Today we are going to move on to the next topic in ship stability, and that is about the list. So I will go through the this some theory part of the list to understand how to uh, solve the questions related to list. So what is a list? List is the transverse inclination. You can see there is I have drawn a transverse section of a vessel. So if there are the weight distribution on the center line about the center line on the port side and starboard side is unequal, then the ship will incline towards the side which has more weight. Now in this diagram you can see that there is a transverse section earlier and there is a weight here W. Before this weight was loaded, the ship's center of gravity and the buoyancy were in a vertical line, equal to each other and in a vertical line, like G was vertically above buoyancy. So in this case, there is no lever, no moment is there. But when we load weight W or shift or discharge, now in this example, the weight W has been loaded on starboard side. That will cause the center of gravity of the ship actually to move towards the center of gravity of the weight loaded. That is to the new G1, GG1. But this slant distance, slant shift, we split in two parts. One is horizontal shift and then vertical shift. The vertical shift of the center of gravity will affect kg of the vessel, and the horizontal shift, transversely horizontal, that will affect the ship's list condition. Ship will not be upright, ship will list. So when we are doing the questions on list, GG1, the shift of the ship's center of gravity, that is the transverse shift. In the formula, it is a transverse shift. Okay, so where W was loaded, it has caused the ship's center of gravity to move off the center line and it has come to G1. Now what is happening from G1, the ship's weight is acting downward, and from center of buoyancy, the center of buoyancy is acting upward, and both are now forming a couple. The ship will start listing, inclining towards starboard side until the time the center of buoyancy will also shift out, because ship is now inclining towards starboard side. So there will be more water on the starboard side, more volume. So center of buoyancy will now shift to the starboard side, and the ship will keep on listing until the center of buoyancy comes directly below the center of gravity. So G had first the G shifted to G1, then the ship inclined, then B shifted to B1. And now B1 and G1, the new center of buoyancy and new center of gravity, are vertically above each other. So there is the ship will now be called at static equilibrium once they are vertically in line with each other. So this angle at which the ship has inclined and the ship has come to static equilibrium at that angle, that is the angle of list here. So we can see in this triangle GG1M, tan theta is GG1 upon GM. Okay. Tan theta is GG1 upon G. Once again repeating, this GG1 is a transverse shift of the ship's center of gravity from the center line. Okay. Now, what is the listing moment here? There is a couple. Couple is two parallel forces, unlike parallel forces, and they are not in a line. They are separated by a lever GG1 here. So this is forming a couple, and the moment caused by the couple is the, because both forces are equal in magnitude. So any force multiplied by the perpendicular distance between them, the lever arm. So here the force is our ship's displacement, weight of the ship, which is acting downward, and GG1 is the lever arm. So the ship's center of gravity has shifted from G to G1 transversely. So ship's displacement W multiplied by GG1 will be the listing moment. W multiplied by GG1, transversely shifted GG1 will be the final listing moment, because the weight has been loaded or discharged already, and the displacement is final displacement. W is the final displacement because it is acting from G1. G1 is the shifted center of gravity. The new center of gravity is G1. So from there the final displacement W is acting. So it will be final displacement into GG1. This is the listing moment. So in order to find how much the shift center of gravity has shifted, the transverse shift of GG1 will be final listing moment upon final displacement. Now, listing moment, what should be the listing moment equal to? W into D. What is this W into D? It is the weight which we have loaded, and D is the distance of the weight from the center line. So in this example here, we have loaded this weight W. So we need the distance of this weight from the center line. That is D. So weight, small w, weight loaded, into D is the distance from the center line. That is the listing moment upon displacement, final displacement. So if there is one weight, you can use this formula, small w into D. D is the distance from the center line. If there are several weights, some weights are loaded on port side, some are loaded on starboard side, some are discharged. In that case, we make a tabular method. We will write individual weights multiplied by their distances from center line, and if the weight is causing listing moment to port, we write under the port. If it is causing listing moment to starboard, we write under the starboard. Under two columns we make for port and starboard. So all the weights causing listing moment to port, they will be put under that column, and all the weights which are causing listing moment to starboard, they will be written together under that column. Then we add them up and we see which one is bigger, and we get the net listing moment. So if, for example, if starboard listing moment is bigger than the port listing moment, then starboard minus port listing moment will give us the net listing moment to starboard. Like that, you get the final listing moment. If the weight is shifted on board, the displacement will not change. So there will be no change in the displacement. The original displacement will remain. And D is the distance from the center line. But if the weight is loaded or discharged, then D is the distance from center line. If the weight is shifted on board, then D is the distance by which the weight is shifted. Okay. So if the weight was suppose 5 meters on the port side and it is shifted to 5 meters on the starboard side. The D will be 10 meters. Distance by which the weight was shifted. The D will be that in that case. So this is the most important thing to understand here, that listing moment, final listing moment is the W into GG1. Final displacement of the ship multiplied by GG1. Now, how do we get GG1? Final weight we can always get. In order to find GG1, we take the help of this triangle, this formula tan theta is equal to GG1 upon GM fluid. So tan theta is equal to GG1 upon GM fluid. Okay. And W into GG1 is the final listing moment. These two formulas, they are going to solve all the questions, the combination of these two. GM fluid is there in the formula. So, you know, GM fluid is Km minus Kg minus free surface correction. So, if the weights which are loaded or discharged have also affected the ship's kg, then we have to find the final kg of the ship. Final kg of the ship we have to find. Then from the km we subtract the final kg, we get the final gm, and then we have to also find the final free surface correction, because free surface correction also is equal to free surface moment upon displacement. If displacement has changed, FSC will also change. So FSC to be found using the final displacement. Then we get the GM fluid, which you use in the formula tan theta is equal to GG1 upon GM. Now, there are some questions which are regarding the use of a derrick or lifting gear. So, here the understanding is that when a weight is just lifted by a derrick or any lifting gear, the center of gravity of that weight shifts to the derrick head. Okay. So if the weight, suppose the kg of the weight, so it means its center of gravity from keel. Kg of the weight was 5 meters, and the derrick head, your crane, is about 20 meters from the keel. Suppose as soon as you just lift the weight, you have not swung the weight. The weight is still in its location only. The distance from center line is still the same. That has not changed, but weight has just been lifted. As soon as the weight has just been lifted, the center of gravity will shift to the derrick head. So before it was 5 meter, now it will become 20 meters. Okay, because the derrick head is 20 meters from the keel. So from 5 to 20, that means it is like as if the cargo has shifted vertically upward by how many meters? 15 meters. So before the kg was 5 meter, now kg is 20 meters. So 15 meters is a shift vertically upward of the cargo's center of gravity. This is we're going to use to calculate the final kg. This will affect the kg of the vessel. You know how to calculate. Then again the same formula is there. W into D upon final displacement. Uh, in this case, in case of vertical shift upward and downward, the D is the distance between the ship's center of gravity and the weight and the cargo center of gravity. In case of loading and discharging, in case of shifting, again it is the distance by which cargo is shifted. So when you lift by derrick, then it is like the cargo has shifted vertically upward, and that will be the like in a difference between the two kgs. I have some question here practically which came in the last papers on this derrick thing. We will solve that, so it will become very clear what to do with these questions. Okay, that was all for the list part. The theory part, it is well understood. What is how is the ship listing and how do we calculate? Now I will do some question, and then the next video, immediately after this video, I am putting up question on the list. There will be 2 questions. All right, thank you very much, and wait for my next video.